some uncertainty problems here. Let's see, I want to choose a couple of ones that are kind of pertinent. So let's do this one here. This is an addition problem. This is a subtraction problem, but it's exactly the same as this one up here. And so the uncertainty part will actually come out the same. I'll kind of explain why, but I won't actually do the math on that. I'm going to do this one because I want to show you how to deal with that percentage there. And then we will do these two problems here, A and B. So let's do this one and this one and this one, these four problems. Okay, and so the way you deal with uncertainties, what's happening here is there was a measurement that was 2.60, but that last digit was uncertain. And so it could be some range between 2.65 and 2.55. And then the same thing with this one. You have a 13.02, but the range is the 100th column there. It's uncertain. So it could be anywhere from 13.10 if you add this, or 12.94 if you subtract it. So first thing I always try to do is to get the actual math done on the certain part of it. So let's add the 2.60 and the 13.02 together. So I have, well, it'd be easy enough, right? It would be 2.60 plus 13.02 is equal to 15.62, but we'll just say 15.6 because we only have three significant figures. Okay, so that's the first part we're going to have, and we're going to put that in our problem later after we figured out the uncertainty. So to get the uncertainty, what I want to do is I want to do this problem, 2.6 plus 13.02, but make the numbers as large as possible. In other words, add these uncertainties into it. And then I want to subtract the smallest possible numbers, and then I'm going to divide it by 2. So here's how I'll do this. I'm going to take the 2.60 plus the 0.05, so that would be 2.65. And then I'm going to add that to the 13.02 plus the 0.08, which is going to be 13.10, okay? And then I'm going to subtract the same numbers, only the smallest version I can get, so 2.60 minus the 0.05, which would be 2.55, and then we will have 13.02 minus the 0.08, which would be 12.94. And then I'll just divide the whole expression by 2, and that will give me my new uncertainty. Okay, and so I'll do the math on this really quick. And that comes out to 0.13. When we're doing uncertainty, we only want to use one significant figure every time, so I'm going to round this up to 0.1. So my final answer is 15.6, which we got from this and this, plus or minus 0.1. Okay, now on this one, this is a subtraction problem, so my first number will be different, obviously, 2.6 minus the 13.02, so that would be 10.42, but a negative. But as far as the uncertainty goes, this is set up exactly the same way. It just turns out that if you just go ahead and treat this as an addition problem, it always comes out the same way. So I would do the exact same thing I just did here, where I would take the largest minus the smallest, divide by 2. So this is going to have plus or minus 0.13, which we will round to 0.1. So treat it as, like as an addition. I mean, do the initial problem as a subtraction problem, this minus that, but then after that, treat it like an addition problem. Okay, this is the same thing. I have another addition problem. The issue with this one is that I have a percentage. I can't put a percentage in there. And so to get rid of that percentage, I'm going to take 10% of 3.4. And so it's easy enough to do. We'll set it over here. 10%. We'll divide out that 100% issue, and we'll multiply that by 3.4, which is going to equal 0.34. Okay. Now, theoretically, we could just leave that 0.34 in there, and then take the sig figs afterwards. But I'm not waste my time with that and just put it in as 0.3. So right now, I'm going to assume that this is actually 0.3. Okay, because we took care of the percentage, and then we'll just go and do what we did before. I'm going to add the 2.6 and the 3.4, which is going to be 2.6 plus 3.4, which is going to equal 6.0. And that'll be the first part of my problem. And then I'm going to make this as large as possible. So 2.65, this plus this, plus 3.47 or 3.7, this plus this. And I'm going to subtract the smallest number, which would be this minus this, 2.55, plus the smallest number here, 3.1, because I'm going to subtract out that. So 3.1, and then I will divide that whole number by 2. So when we do the math on that, 2.65 plus 3.7 minus 2.55 plus 3.1 divided by 2 gives me an answer of 0.35, which I have to round to 0.4. So my final answer is going to be 6.0 plus or minus 0.4. Easy peasy, right? Okay, 2 more. Multiplication is done the same way, except we multiply instead of add. So I'm going to start off by getting my actual number, 2.6 times 13.02. 2.6, I get 3 sig figs total, so whatever my answer is, I get 3 sig figs times 13.02. Comes out to 33.85. So 2.60 times 13.02 is equal to 33.9. Okay? And then the next part is, I'm going to make this as large as possible, 2.65. And then we're going to multiply it by as large as possible here, which would be 13.10. And then I'm going to subtract, just like we did up here, the smallest possible number, which is going to be 2.55 times 12.94. And we'll divide the whole thing by 2. And so let's see, 2.65 times 13.1 minus 2.55 times 12.94, and divide that by 2, and we get a number of equal to 0.859, and we only allowed 1 sig fig, so it's equal to 0.9. So our final answer is 33.9 plus minus 0.9. All right. Now, kind of pay attention to this one, because division problems can be just a little bit tricky. You got to kind of manipulate it a little bit to get the smallest and the largest. So here's how I want to do. First, I want to take the 13.02 and divide it by my 17. Okay. I also have an 8 there, so let's take care of that 8% first, I guess. So I want to have 8% of 17. So that is going to, I'll set this over here. 8 divided by 100. That's my percent issue. And then we'll multiply that by 17. So 8 divided by 100 times 17 is equal to 1.36. So we're going to scratch this out, and we're just going to put in a 1, okay? Again, we may possibly want to put in 1.36. I don't think that that number is going to affect our calculation, though. But if you're, you're really worried about being perfectly accurate, you probably should put in the 1.36 and then fix the sig figs afterwards. But we're going to do this for now. So here we go. I'm going to take, first of all, 13.02, and I'm going to divide that by 17, okay? And that gives me a number of 0.77, okay? So this number times this number is 0.765 or 0.77. So that's the number we're going to get when we divide that. And then I'm going to go and I'm going to say I'm going to take 13.10, okay, that's this number plus this number, right? And I'm going to divide it by, not the biggest number over here, but the smallest number over here, so 16, so 17 minus 1. And the reason is because this will give me the largest outcome, right? The biggest number divided by the smallest number in a division problem gives you the largest outcome, and I want the biggest number possible over here. And I will subtract out 12.94. So now I make this the smallest number possible and this the biggest number possible. And I'll divide that by 18. Okay, so that's a little weird when you do division. Just remember that. It's always going to be biggest divided by smallest minus smallest divided by biggest, and that'll give you your biggest outcome, your best outcome. Then divide by 2, and we'll get our answer. 13.1 divided by 16 minus 12.94 divided by 18 divided by 2 gives us an answer of 0.0499. Okay, and which we're going to round up to 0.05. So our final answer is going to be 0.77 plus or minus 0.05. So there's the answer to that. This is the answer to this one. This is my answer here, my answer here, and my answer here. Okay.